Okay, well, let's do a times the square root of 20 plus b times the square root of 5. Everybody has their own a, b, and c. So in my case, this would be 4 times the square root of 20 plus 5 times the square root of 5. Okay. Now what you have to see is the square root of 20. The only difference between this step and this step is I've written 20 as 4 times 5. Why would I do that? Because I know the square root of 4. Calculate the square root of 4. So I take the biggest square that goes into 20 and factor 20 by that square. Okay. Now, there's no square root. There's no perfect square of an integer that goes into 5, so we don't do anything with 5. Then we write this as 4 times the square root of 4 times the square root of 5 plus 5 times the square root of 5. Because square root of product is the product of the square roots, as we saw earlier. Now, one thing you don't want to do is you can't multiply the 4 here by the 20. Okay, that doesn't work at all. The multiplication doesn't distribute over a radical sign, square root sign, or a cube root sign. Okay, just doesn't work. And you can easily see that it doesn't. Okay, well, square root of 4 is 2. So I get 4 times 2 square root of 5 plus 5 square root of 5. 4 times 2 plus 3. 8. So now I have 8 square root of 5 plus 5 square root of 5. Okay. Then by the distributive law, well, we can factor square root of 5 out of it. Okay, so this is 8 plus 5 times square root of 5. And that's 13 times the square root of 5. Okay. I'm going to give you another one. So let's try. Do that too. Okay, I'll give you a minute to do that. And pause the video. Okay, people did real well with this. Okay, on the whole. A few little problems, but it seems to work pretty well. So let's say we've got 6 square root of 48. Four times the square root of 75. The square root of 48. Now let's work this out a little bit. Okay, first of all, if the numbers get big enough, you're going to have trouble identifying the biggest square. Okay. Now these numbers aren't so big. You can see probably that 16 will go into 48, right? 3 times. It depends whether mental arithmetic's up to that or not. Okay. Hopefully it is, but maybe not. Okay. And of course, 4 would go into 48. But 16 is a bigger square than 4, right? Now 4 goes into 48 3 times. 3. Okay, 3 times. And 3 doesn't have any squares as factors. 75. Well, that's 3 times 25, isn't it? Naturally, 4 is not going to help because 4 won't go into an odd number, right? 9 is a perfect square, but 9 into 72 is 8, right? So you're going to have remainder. That's not going to work. 16, forget it because it's even. But 25 goes into 75 3 times. Well, so for these numbers, we really should be able to identify the square without having to do a lot of prime factorization. So sometimes you need a prime factorization. So let's just do that. 48. I prefer to write it this way, but I've written it other ways, and you know the way your videos show you to do it, as long as you understand what you're doing. But this shows you clearly what you're doing, okay? Okay, well, 24 is 2 times 12, right? And 12 is 2 times 6. And 6 is this, right? Of course, that could be written 2 to the 4th times 3, and there's an easy way to simplify if you know that. Let's stick most basic breakdown, okay? Now, another way of writing this would have been, okay, here you got the 48. 2 goes into 48 24 times, 2 goes into 24 12 times, 2 goes into 12 times 6 times, and 2 goes into 6 3 times. Then you got 2 times 2 times 2 times 2 times 3. This is a little more abstract why this gives you the result, although it's an easier process. It's quicker to write out. This shows you exactly why it works. So I prefer to do this. But if you understand this, feel free to use this, okay? Especially if you understand why this tells you the same thing this way. Okay, well, you then have 6 times the square root of all this, right? And similarly, 75, this is a little quicker, equals 3 times 25, which is 3 times 5 times 5. That comes out very quickly. Of course, you write it out this way, it's even a little quicker. Okay, well, what can we do with this? I'm going to say we can do this. I can break all these 2 times 2 times 2 times 2 into pairs, 2 times 2 and 2 times 2. So now I can write this as a square root of 2 times 2 times 2 times 2 times 3, right? Now, why would I do that? Well, let's see. And that's plus not equal. Okay. So same thing with the 5s. I can pair the 5s up. Now, what's a square root? It's a number you square or multiply by itself to get another number. So it should be clear. The square root of 2 times 2 is 2. So each square root of 2 times 2 gives us this 2, right? You multiply it out, you get 4. Square root of 4, you know it's 2, but why is the square root of 4 2? Square root of 4 is equal to 2 because 4 is 2 times 2. Square root of a number by itself is just that number, assuming it's a positive number, not a negative number. Okay, well, And the rest is easy. You know, 5 times 5 is 5. And now we just multiply these out. We get 24 square root of 3 plus 20 square root of 3. And that's 44 square root of 3. Now, if I come back to this step, I'm looking at how to arrange board space and avoid Zoom watermark, which obliterates everything. Guess I'm willing to look for that. Okay, well, okay, I can write. I want to write it over there. I've got enough room. 6 times the square root of 48 plus 4 times the square root of 75 equals what? 6 times the square root of 2 to the 4th times 3. Instead of writing out all these 2's, I'm going to write out 2 to the 4th. Okay. And instead of 5 times 5 times 3, I'm going to write 5 squared times 3. And what's this equal? Well, this is 6 times the square root of 2 to the 4th. Times the square root of 3 plus 4 times the square root of 5 squared times the square root of 3. Now, what's the square root of 2 to the 4th? Well, square root of 2 to the 4th is 2 to the 2nd. Because you multiply 2 to the 2nd by 2 to the 2nd, you add the exponents. Okay, this is because, again, well, like the square root of 2 to the 4th is 2 squared because 2 squared times 2 squared. Same base, you add the exponents. You get 2 to the 2 plus 2, which is 2 to the 4th. Well, then we can finish this. I'm just going to put an etc. here because it works out the same as this does. You can do that arithmetic once you're at that point. Home free. Okay. So now let's take a look at. Move this over just a little more, just in case this is obliterated, but there it is. Let me lower the thing a little bit. Unfortunately, this camera, which is just wonderful, has a remote that just moves things in big jumps. A little hard to get it to stay exactly what we want. But anyhow, there it is in case you couldn't see it. Okay, so what would you do with something that came out like this? So work on that a little bit, see how we do. Okay. Everybody even finished that up in the time I gave you, or it is right on track for doing, so very good. Okay, now that's a B, not a apostrophe 6. But in this case, it'd be 5 times square root of 3 to the 5th times 2 to the 3rd plus 6 times the square root of 5 times 3 to the 3rd. Now, I want to take out an even number of 3s. In other words, you got 5 3s multiplied together. I know if I take an even number, then I can group those into 2s. We'll do this. So that's going to be 5. I'm kind of skipping a step here, but step everybody's stuff that's comfortable with. Times the square root of 3 to the 4 times the square root of 3 times the square root of 2 squared times the square root of 2. Everybody agree with that? Because I've got my 3 to the 5th here and here, right? And of course, I've separated the grouping of the factors into the square roots of those factors. We understand that. Okay, 2 to the 3rd is 2 to the 2nd times 2. So that seems to be okay. Then we have 6 times the square root of 3 squared times the square root of 3 times the square root of 5. You're just keeping everything as factored as possible. Then square root of 3 to the 4 is 3 squared. And then if you did, 3 to the 4th is 3 times 3, and then another 3 times 3. So you got a square root of 3 times 3, square root of 3 times 3, right? And that's fine, but that's going to come out 3 squared, isn't it? Okay, since we're going to get a 3 from each of those. And we still have a square root of 3. I'm going to keep these in order. Although I'd probably try to do that. I'd get 2 out. But then I have this, right? And I think everybody's clear on how we get this. Square root of 2 squared is 2. And that's by common sense, is what the square means. Also by the laws of exponents. Okay. And we're going to get to the laws of exponents for fractional exponents. Square root of 3 squared is just 3. Then we still have a square root of 3 and a square root of 5. Well, now we can just multiply our numbers out here. 3 squared is 9. 9 times 2 is 18. 5 times 18 is 90. I'm going to keep my square roots as square roots for just another step. Now I have a couple of options how I can do this. I can factor out the square root of 3, right? So I can write this as in this form if I want. There are times when you want to write it in this form. Does that make sense? Okay. Let's play the distributive law. Since I have that square root of 3 as a common term, this is what I get. And I can check that. I just want to check this by multiplying all this out and making sure I get this. Because, again, all I'm doing when I factor is no magic to it. It's just a backward distributive law. You want to try to remember that. Okay. So that's perfectly good. But maybe we just want integers in here. Maybe we don't want square roots in here and out here. Okay. Again, it depends on what form gives us the best information. And we get to make that decision unless you're told what form to put it in. So I would accept this as a simplified form. Not sure open math would. So you can figure out what open math was. Then so this is one alternative, okay? So let's just say here's one alternative. Used to write out the other alternative. Okay, the other way is keeping the square root of 6 and the square root of 15 as basically unlike terms, right? And this is also valid. Okay. So when you do an open math, do whatever they want to be valid, but be aware that there are two ways to do it, okay? Because when you get into symbols, symbolic expressions, sometimes you want it one way, sometimes one or another. Okay. I'll give you one that you want to definitely apply the laws of exponents. So make sure you understand this. So let's say we've got okay. So do this without writing out 37 sevens and 37 twos, right? But you can do something similar maybe to what I did. Let me go ahead and move this. Oh, here we see it. I guess you need to look at it. Okay. if you're just a little bit stuck, some of you aren't, some of you are, it's about half and half. If you were going to write out pairs of sevens, right? How many of the sevens would you cover with pairs? Or if you write out 2 to the 5th with pairs, well, if you pair them up, you can pair them up. You can pair up 4 of them, but you can't pair up the last one, right? Well, how many sevens could you pair up? And how many would you have left? Now, if you've already seen that, just keep going. So, yeah. Okay, good. Now just, well, yeah, I'm not going to ask you about that. Although, calculator. Yeah, it's a big number. So we would usually just kind of leave that number in that form, or we would put it in a scientific notation, which might be approximately 1.628 times 10 to the whatever that is, 17. Okay. Well, you see how I put that into 2 forms? And you've got it in what would be second form, right? Okay, well, no, actually, we have a square root of 14 now. So actually, you don't have 2 forms. You can just factor all this. Back up, that's what I think. So if you do, and it's still going to be a big number if you don't have it. To pair them up, you have one of those. And the pairs. First thing is, if you pair them up like that, you're going to have 7, 3, 36. I'm 7, right? Okay. You pair them up. So 7 to the 13th times 7, you don't have 14, 7. Right? You have 37. So we have to change. So we like this. Okay. But you see enough, you're gonna understand what you do. Okay. Somebody got it, somebody did some neat stuff, got off a little bit on the wrong track. Somebody did my chalk, and if I find out who did it. Okay. Okay. Okay, looks like I forgot to stop the recording, so don't take that threat, you know, I find out who did my chalk. Don't take that seriously, I didn't mean it. Besides which, everybody in here could kick my butt, so don't worry about me. Okay, now, here we got it. Okay, so I'll use my letter T, whatever that happens to be. That would be, okay. Actually it'd be 13, but I'll just look up the numbers here. Okay. Well, I want to group this so that if I was doing what we did before, I'd want to write out 7 times 7, 7 times 7, and 7 times 7, right? But I have to write out a bunch of them. But whatever I did, when I did all the grouping, I'd have one left over because 37 is an odd number, right? So that kind of gives me a hint that maybe I want to group this 7 to 36 times 7. And over here, the 2 to the 5th. The 2 to the 4th times 2. Similarly over here. I've got 5 7s multiplied. I want to group 4 of them so I can group them in 2s, right? And I've got 37 2s. I want to group 36 of them. Okay, because then I can group those into pairs as we've done. And I know that's going to work. I'm going to choose to write this expression like so. I'll keep the 7 and the 2 together because I know I'm not going to be able to factor them. Okay. And these, I know I'm going to be able to factor. Okay. So that should be pretty obvious. Again, why do I factor in an even number of 7s and an even number of 2s? Because if I've got an even number of 7s, I can group them in 2s, nothing left over. Okay. Now, if I group 36 7s in pairs, I'm going to get 18 pairs, right? Now, I could write that as just 14 times the square root of And we're thinking about how to write that out. Make our decision. I can write 7 to the 36 is 7 to the 18th square, can I? Not necessarily the way everybody did it, and what everybody did was good. And the square root of 2 to the 4th. Is the square of 2 squared. Okay. This is square of 14. 7/4 is the square of 7 squared. 2 to the 36 is square root of 2 is 2 to the 36, 2 to the 18th squared. 7 times 2 is again 14. Well, the square root of the number squared is just that number. So this is 14 times 7 to the 18th. And 10 times 2 squared squared. Well, that is 2 squared. And 17 times 7 squared squared is just 7 squared. Well, 7 squared squared is 7 squared. I'm not saying that, right? 2 to the 18th squared is 2 to the 18th. Then we have the square root of 14. Now that's a symbolic way to see that if you are multiplying 36 sevens together, okay, and take the square root of that, well, that's 18 pairs of sevens, okay, or a pair of sevens to the 18th, or whatever. In any case, you're going to get 18 sevens. Take the square root of this, group them in twos, you're going to have 18 groups of 2. 18 groups of 2 matches this. And in doing it this way, I use the rule of exponents. 7 to the 36 is 7 to the 18th squared. Also 7 squared to the 18th. Okay? And the way you group them, it's like 7 squared raised to the 18th. I chose to group it this way because now we have a perfect square. And the square root of a perfect square is just what we're taking the square of. Okay? So we have this and this. This all reconciles with what you do if you group these things. Now, these numbers are unmanageable. Okay? 2 to the 18th is like over 250,000. And 7 to the 18th, let's see, that would be 50 to the 9th. 50 cubed is 125,000. 125,000 to the 3rd is over 10 to the 20. No, it can't be over 10 to the 20. Okay. Anyhow, there we have 14 times 7 to the 18th times 2 to the 2nd plus 17 times 7 squared times 2 to the 18th times the square root of 14, factoring the square root of 14 out. Now 2 to the 2nd, 7 to the 2nd are easy numbers, but then you got to multiply by 14 and 17. Might as well leave them like this. So you put them in the calculator, because the number you write out here wouldn't have a lot of meaning to you. Okay. Or to me, unless I count the number of digits. And it probably compare it to the number of molecules in virus or something. Okay. Okay, well, there we go. Now that's quite a bit about the rules of exponents. We're going to look at a little more formally at what we can do with radicals and expressions of this nature. Okay, now we want to talk about radicals in terms of exponents. Okay. First of all, remember I was writing down what I'm going to write down, which is what it isn't. It's not a to the b raised to the c. B isn't raised to the c power. All this means is you've got c, a to the b is multiplied together, right? Okay, so you got a to the b multiplied by itself c times, right? Okay, so how many of them you got? Well, this a to the b, you got BAs. You know, you get a written b times. And that means you've got this, which is this, and this, which is this, all the way out to this, which is this, and that's written c times, right? And what that is that equals b times c times. Because you got c groups with b in each group, you got b times c of the term, okay? So you have to understand this. So you always know what the rule is and understand why it is so you don't make a mistake of doing something like this. Also, again, just so you understand it. Okay, well, yeah, the other rule is, of course, a to the b times a to the c is a to the b plus c. Because this means you write out a b times. This means you write out a c times. You got b plus c. I'm not going to write that out, but pay attention to it when you see it in the text and when you see it in the video. Okay. Of course, I think you've already seen it. You want to make sure you get that picture. Okay, so what's a to the 1/2 multiplied by a to the 1/2 now? Which rule applies? This one or this? Just point. That way, point this way. Okay. And one person just pointed. Most of you haven't, and most of you are still with. It's this one, because you're not raising a power to a power. That's just you multiply power of A by power of A, right? That's just A to the B. B and C both equal to 1/2, right? So A to the 1/2 times A to the 1/2 equals A to the 1/2 plus 1/2. Agree? And that's the rule. If I told you A squared times A cubed, you'd tell me A to the 5th, wouldn't you? I hope. Okay. What's 1/2 plus 1/2? The signal with the correct number of fingers. 1/2 and 1/2 is 1. So this is just A to the 1/2 squared, isn't it? And it's got to be equal to A. So A to the 1/2 squared equals A. If something squared equals A, something you're squaring is the square root of A, right? So the square root of A has to equal A to the 1/2. Now, let's look at square root of 7 to the 37. If the square root is the 1/2 power, then this is 7 to the 32nd, 7 to the 1/2 power, isn't it? Now, which rule can you use to express this with a single exponent? This rule or this rule? Point. Which rule applies? It's this one because you have a power of a power. You have the 1/2 power of a 37th power. You're not doing 7 to the 32nd times 7 to the 1/2. You're doing 7 to the 37th to the 1/2 power. So that's 7 to the 37th times 1/2. So it's 7 to the 37.5 power. Okay. Now that isn't particularly useful or helpful, although I think it could be. But for what we were doing before, we could also write this as such. Square root of 7 to the 37 equals square root of 7 to the 36 times square root of 7 to the 1, right? Of course, I just square root of 7, and that's when I'm going to write it next time, okay? And what's the square root of 7 to the 36? That means 7 to the 36 to the 1/2. Times 7 to the 1/2, right? Let's make the eliminate that 1. Square root of 7 just 7 to the 1. Okay, what's the square root of 7 to the 36 to the 1/2? 7 to 36 halves. And that's where you get the 7 to the 18th. By using this rule. You don't have to group a bunch of them in two, although you can visualize doing that. You know how to do that. You know that you could group 36 of these into 18 groups of 2. And the square root of each group of 2 is just 7. So that's why you have 7 to the 18th. Okay? And that's the most direct reason why it is. You get 7 to the 18th out of this. But the rule is totally consistent with that, as it must be, if it's a good rule. Okay. So you use that rule to simplify this stuff. And you're going to see that in upcoming assignments. You see that idea and that use of these rules of exponents. So number one, you need to be really straight on these rules. Okay. And then secondarily, but sort of importantly, you need to understand the process we've been doing can be formalized using the exponents. Okay. Now, okay, that's the meaning of a 1/2 power. It's a square root because you multiply the 1/2 power of a number by itself. You will add the exponents, the 1/2 and the 1/2 to get the 1. Gives you the number. 8 to the 1/2 times 8 to the 1/2 equals 8. So 8 to the 1/2 must be the square root. I think 8 to the 1/3 things. Well, if you multiply 3 of these, the exponents add. So 8 to the 1/3 is what you would multiply 3 of to get A. The thing you multiply 3 of to get A is the cube root. I'll say it's the third root. Or cube root, because multiplying something by itself 3 times. 3. Well, hard to say that in English. Anyhow, but you understand what I mean. 3 of these multiplied together give you A. So this number is the cube root of A. Because cubing the number gives you A. Okay? Another way to see that. If you cube A to the 1/3, then you take the third power of the 1/3 power, meaning you're raising A to the 1/3 times 3 power, which just gives you the first power. 2 times 1/3 is 1. Of course, that's also written as a cube root of A. Okay. A bit more to it. Well, I don't want to say anymore if you understand that. Then once you open that, probably going to be seeing you'll have a pretty good understanding. Zilla, okay? So